Hello, this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 3-4 in the SavvasRealize Algebra 2 textbook. So in this example, we are looking at identifying even and odd functions from their graph. So first, I want to define those for you. So here's some graph paper so we could discuss it. Pretend I know how to draw, please. So when you have an even graph, it is symmetric across the y-axis. Which means, like, if you were to fold it in half across this vertical line here, it would map onto itself. So some examples of even functions are like a parabola, the parent function parabola, y equals x squared, or sometimes you might get ones that look like this. They look like W's. I don't actually know what function that one is, but it happens. Yeah, so that's what we mean by an even function. Now, an odd function is symmetric about the origin. So, for example, an odd function would be this one, like y equals x cubed. So if I were to rotate this graph about the origin by 180 degrees, it would map onto itself. So let's go ahead and let's try some of them. So on this one, they actually drew the same graph that I drew, only a little bit better. So notice it goes through the origin. And so if I were to rotate this graph 180 degrees, right, I'd take this one up and then move it again for 180 degrees of movement. And do you see how it would graph onto itself? So this is an odd function. Now for this one, if I draw my axis of symmetry here on the y-axis, and I fold the graph in half, do you see how this one is 2 away, and this one's 2 away, and here it's like 2 and a little bit, and here it's like 2 and a little bit. So because it's symmetric, this is an even function. Now this one, it looks like it would be an odd function, right, because it's the same shape as the x cubed. But remember, odd functions are determined based off of the origin. So if I rotate this about the origin, right, I go 2 and 2. So I'm rotating this 180 degrees. Let's see, that would put it here, and this one would go down 4 and over 2. I don't actually know how to rotate very good. We're gonna not do that because I think it'll be less clear about what I'm saying. But if I were to rotate this graph 180 degrees, it would go through here, through -2, and it wouldn't map onto itself. Do you guys see that the y-intercept would move by rotating it? So this is not odd. Oops, not add, odd. Okay, and again, does not rotate. And then I could check to see if it's even, right, by seeing if it reflects across this line here. But if I look at it, it's not even because if I fold it on that green line, it's not symmetric, right? So it is neither even nor odd. Now this one, again, it's clearly not even, right? Because if I fold it in half here, I'd get a shape like this. It's certainly not even. It's the odd ones that I struggle with because I have a hard time visually rotating it. So here I'm putting my pin in my origin, so that's a good sign for odd. So it goes 2 to the left and 4 up. This one goes 2 to the right and 4 down. So it is symmetric about the origin. So this is an odd function. Maybe that's a way to explain it up here. So here, if I were to go and take this point 180 degrees around, it should be over here, but it's not. And this one goes up 4 and over 2, but if I go over 2 and down 4, it's not in the same spot. That might help a little to say. Alright, so now this one, right, if I were to reflect it here, you could see it easily folds onto itself, right? It's 1 unit away here and here. It's about 2 units away here and here, so this is certainly an even function. Now to check for oddity, right, I would rotate this around the origin 180 degrees. So like it should rotate and be up here. So this is telling us it's not odd because it's not on top of itself. Alright, so that's how we look at a graph and determine if it's even, odd, or neither. Until next time.